Every minute, enough of the sun's light reaches the Earth to meet the world's energy demand for an entire year. What if every house, every building in an entire city could collect that energy? Since Bell Labs' creation of the first viable silicon photovoltaic cell in 1954, people have dreamed of this kind of cheap, plentiful solar power. Now, a small Palo Alto company called Nano-solar may finally be putting this futuristic concept within reach.
The challenge in the solar industry is to have products that can efficiently convert sunlight to electricity, but do so at a reasonably low cost.
Traditional photovoltaic cells have typically been made out of crystalline silicon. They're expensive, heavy, and fragile, and have to be installed in a supportive frame.
Silicon, for all of its structural perfection and purity, does not actually absorb sunlight all that strongly. There are certain thin film materials that absorb light anywhere from 100 to 1,000 times more readily. And because of that, you can use very thin layers of those materials. The challenge is to find techniques by which you can make those thin layers in very high quality and a very low cost.
Nano-solar intends to accomplish this by repurposing high-speed fabrication techniques and machines typically used in large-scale electronics manufacturing. Here's how Nano-solar's process works.
One of the first steps is to deposit an electrode layer that will collect the electricity. The next step is to deposit the optical absorber layer, which actually will absorb the sunlight.
In this machine, the optical absorber layer, a mixture of copper, indium, and selenium nanoparticles, is printed directly onto the foil.
Then on top, you put another electrical coating that collects the electricity from the top and also allows the sunlight to come through.
Nano-solar projects that the finished product will cost about 1/3 that of traditional solar cells. The company is currently building what will be the nation's largest solar manufacturing plant in San Jose and plans to bring products to the market in 2008.
With the new generations of photovoltaics that are coming that are based on flexible materials, they can be basically rolled onto your roof, not unlike flexible roofing materials that houses have. So you could power most everything in your house with solar today and hook up that power to the electrical grid. So in the daytime, when your solar panels are delivering more power than your house could possibly consume, you can sell it back to the utility and turn your electric meter backwards, only then to buy electricity from the utility at night in a seamless fashion, no batteries at your house, nothing to figure out.
In this vision of the future, a thin film-covered city might drive the electrical grid itself, essentially functioning as its own power plant.
Increasingly, you'll see it everywhere, or you won't see it, but it will be everywhere, powering your life just exactly in the way you live it today.